Wear detection is basically a device to determine a wear event down the hole during a pumping exercise. So what generally happens then is you've got a sucker rod from the surface being operated down to a downhole pump. If they're not protected by sucker rod guides, the tubing will be worn against the rods and put a hole in the tubing. And the problem with that, of course, is you lose production because then it's just pumping up to the hole and then back down to the well, and then you're up for a very costly workover. And in Australia, for example, that's probably nearly 100,000 Australian dollars per unit. To combat it in the first place, they've put what they call a sucker rod guide. And it's a sacrificial guide that's there to wear instead of the tubing. And that technology has been around for 100 years. But still, you don't know you've got a hole in tubing until you get the hole in tubing. So we've looked at it, Oilfield Piping Systems, we're the #1 supplier of sucker rods and guides. We manufacture guides here in Australia in our factory in Toowoomba. We're constantly though still seeing that the guides are coming back eventually. We take the existing guides off and put new guides on there. So it got us thinking about how do we detect? The best thing is to have an alarm to know when it's time to pull that fella. So you're not pulling it too soon where you're wasting money, or you're not pulling it too late that you've got a hole in tube.
A wear detection.
And it's a wear detection. It becomes a remote wear detection. So we can send a signal from a worn guide by encapsulating a trace element in the guide itself. Our problem then is how do we detect this? So in a beaker, it's all nice and simple, clear bit of fluid, no turbidity, perfect conditions, and then we can say, right, oh look, we can detect it, tick, it works. That's fine in a perfect world. This isn't. This is a very harsh environment. How are we going to pick up a small trace coming from, maybe 1,000 metres below the surface? Our initial model, if you can recall, was the dome where all this instrumentation electronics had to be, was about the size of half a football. We needed the filtration system, the amplification, the sensors, the communications in there, and we needed to take it, because obviously this is way too big, to bring it down. So we've gone from basically half a soccer ball now to a tumbler, a Scotch bottle, a glass tumbler. So it's a very compact unit.
You gave us the opportunity to explore all the off-the-shelf solutions, but we basically found pretty quickly that none of them suited the application. Turbidity
is a major problem with it. And if you can imagine it's flowing at, 5 metres a second sort of stuff. These sensors were, I don't know, from memory, it was about
plastic sensors,
and they were 5 minutes behind the time. They were constantly having to correct themselves in it. And in most industries, plastic's not going to cut it.
We also needed the sensitivity to be basically at the leading edge of what all the other sensors we'd seen in the market.
They couldn't do it. That's right. I remember when Dan was talking to the suppliers of the sensors, they were almost laughing at him. Why? You want it that quick? Come on, you've got to be joking.
We had to do it ourselves.
We had to do it ourselves. It gave us a lot more flexibility. So we got 300 metres tubing run out there, mimicking the flow that goes through a normal well tube. Same temperature, same pressures and velocities.
Physically wearing out real guides?
Yeah, we've embedded the trace in real guides that we do, and we put them into an OCTG tubing. We put a 20 kilogram side load on them, similar to what they do in the well.
The guys are running that thing 24/7 now, and given enough time and data to be able to create the algorithms and things like that they need to getting proper sensor data that these guys can rely on. Wear Detection Technologies has got the patent on the end-to-end system, but you're also holding a bunch of trade secrets in-house.
Correct,
which is the algorithms and the way we're doing things to try and make the whole thing work.
It is the algorithms that really tie it all together. Without that, you've got the shell of a car, but you haven't got
the engine.
The engine, the transmission, the gearbox, the cooling system. You've got nothing, and you have to really start to work it all out yourself.
We've got the ability to push firmware updates, push algorithm updates to the device at the edge.
The beauty of that communication then too is that you can constantly upgrade it. Each and every day we can trace where all of those units are and how they're performing. So if there's a problem with one, we'll know it before our client does. We've got now our EX certification because we're operating obviously in gas fields and oil fields. So this gives us the opportunity now to put our units right at the wellhead